Good morning. I'm Devasena. In this lecture, we are going to discuss about PLC programming. In detail, we are going to discuss about the structure of a rung, logic functions, latching. This topic is present in the subject mechatronics. Let us start discussing about the topic. PLC programming, structure of a rung. Figure shows a ladder rung starting with the input. Normally open symbol for input contact is shown by the symbol. In drawing ladder diagrams, the addresses of each element are appended to its symbol. When wiring up the inputs and outputs to the PLC, relevant input addresses must be connected to the input and output terminals with its output addresses. Let us discuss the logic functions in PLC programming. There are various control situations requiring actions to be initiated when certain combinations of conditions are realized. Certain conditions are shown by logic functions. Different logic situations, its equivalent circuits, truth table, and its ladder diagram are discussed one by one. And logic function we will discuss. Here is a representation of AND logic function, its equivalent circuit, truth table, and the corresponding ladder diagram for the AND logic function. In this AND logic function, we considered here two inputs, input A and input B. If the two inputs are normally open, the output is 0. When any one input is open, then also the output is 0. The output will be 1 when both the inputs are normally closed. This is indicated in this truth table as well as the ladder diagram. Here we considered two inputs, input A and input B. The OR logic function is indicated here. In this equivalent circuit, we considered two inputs, input A and input B. When both the inputs A and B are normally open, the output will be 0. When any one of the input, either A input or B input is 1, then the output will be 1. As well as when both the inputs are normally closed, then also the output is 1. This is indicated in the truth table. In the ladder diagram, we have represented two inputs, input A and input B, and the output is represented. NOT logic function, its equivalent circuit, truth table, ladder diagram is indicated here. When the input is 0, the output is 1 for NOT logic function. The output is 0 when the input is 1. It is indicated in the truth table. The ladder diagram for the NOT logic function is indicated here. Let us discuss the NAND logic function. The NAND logic function is also called as inverted OR function. The equivalent circuit for the NAND logic function is indicated here. The truth table for the NAND logic function is also indicated here. In this truth table, when both the inputs are 0, the output is 1. When any one of the input is 0, then also the output is 1. When both the inputs are 1, then the output is 0. This is the truth table for NAND logic function. The ladder diagram for the NAND logic function is also indicated for two inputs, input A and B. The NOR logic function is indicated here. The NOR logic function is also called as inverted AND function. The equivalent circuit for the NOR logic function is indicated here. Here we considered input A, input B and the output. From the truth table, when both the inputs A and B are 0, then we get the output as 1. If any one of the input is 1 or both the inputs are 1, then the output is 0. This is the truth table for the NOR logic function. The corresponding ladder diagram for the NOR logic function is indicated here. XOR logic function, equivalent circuit, truth table, ladder diagram is indicated here. In this XOR, when both the inputs are normally open, the output is 0. When any one of the input is normally closed, then the output is 1. When both the inputs are normally closed, then the output is 0. This is indicated here. Latching. There are often situations where it is necessary to hold an output energized even when the input ceases. Example, a motor started by pressing a switch. Though the switch contacts do not remain closed, the motor is required to continue running until a stop push button is pressed. Latch circuit is used to implement such situation. Figure shows the latched circuit. When the input A contacts close, there is an output. However, when there is an output, another set of contacts associated with the output closes. The contacts from an OR logic gate system with the input contacts. Thus, even if the input A opens, the circuit will still maintain the output energized. The only way to release the output is by operating the normally closed contact B. This is indicated in this latched circuit. Let us discuss latched solved example. As an illustration of application of a latching circuit, consider a motor controlled by stop and start push button switches, and for which one signal must be illuminated when the power is applied to the motor and another when it is not applied. Figure shows ladder diagram with Mitsubishi make PLC notations. The inputs for this ladder diagram are X400, X401. Both are normally open switches, that is NO. The outputs are Y430, that is motor, Y431 lamp indication when the power not applied, Y432 lamp indication when power applied. When the input X400 is momentarily closed, the output Y430 is energized and its contacts closed. This results in latching and also the switching off of Y431 and the switching on of Y432. To switch the motor off, X401 is pressed and opens. Y430 contacts open in the top rung and third rung, but closed in the second rung. Thus, Y431 comes on and Y432 off condition. Thank you very much for listening this lecture. If you like this lecture means kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.